This is Note-Taking Guide 4.5, More Solving and Extraneous Solutions. Now, I talked to you yesterday about the importance of checking your solutions when you are solving, just to make sure that they worked. Well, today it's super important because we can sometimes get something called an extraneous solution. So extraneous solutions, sometimes they occur when we end up squaring both sides of an equation. And the reason that that happens is because the solution to a squared equals b squared is not always the solution of a equals b. So when you square both sides of an equation, check each solution in the original equation. So again, just to kind of reiterate what that means is that means extraneous solutions are imposters. They're trying to fool you into thinking they're a correct answer when they're not. Okay, always double check your solutions to make sure they're not extraneous. So here's an example that's already done for you that shows you step by step how to solve this equation. So over here they have already isolated the radical in the very beginning. So now that the radical is isolated, you can square both sides. When you square both sides, it's interesting to note right here that this became a FOIL problem. You had to actually FOIL that side out, the x plus 1 and times the x plus 1, which is why they got x squared plus 2x plus 1. Then you were left with only numbers and variables, but because you have a squared term there, you have to get it set equal to 0. So we moved stuff in order to get that set equal to 0. And then factor came back. We have to factor again. So we're going to find numbers that will multiply to a negative 14 and add to negative 5, which were negative 7 and positive 2. Those always will come out as the opposite when you set them equal to 0 and solve. So these are our two solutions, supposedly. But when we take a closer look at those and we substitute them back in, you'll notice that if we check x equals 7, it checks out and it works just fine. But when we check out x equals negative 2, we get negative 1 equals 1, which is not a solution. That doesn't actually work when you check it. Because that's what happened, our answer is only x equals 7. The other one is what we call an extraneous solution, and we're not going to show that as an answer to our problems. So let's see if we can do one on our own here. We're going to solve this just like we did yesterday, and then we're going to get some solutions and see if they work. So the first thing we're going to do is isolate the radical. So I'm going to start by getting that 7 to the other side. So I have x plus 9 equals x plus 7. The x plus 9 is under the radical still at square root, so I'm going to have to move that radical. In order to move that radical, I am going to square both sides. So squaring here and squaring here. Squaring on the first side just cancels the squared and the square root. Squaring on the other side means I'm taking x plus 7 times x plus 7, and I have to FOIL that out. So x times x is x squared. X times 7 is 7x. 7 times x is 7x. So 7x and 7x makes 14x. And then 7 times 7 is 49. So I combined those middle terms together, so I didn't have to rewrite that twice. All right, now that I have an x squared term here, I have to isolate and set equal to 0. So I'm going to subtract that x to the other side and also subtract that 9 to the other side in the same time to get it set equal to 0. So I have 0 equals x squared plus 13x plus 40. And I'm going to factor this. So I'm looking for two numbers that will multiply to be 40 and add to be 13. So multiplying to 40 and add to be 13, that would be a positive 8 and a positive 5. When I bring those back out of my parentheses, I get x equals negative 5 and I get x equals negative 8. Now it's possible that these are solutions, but it's also possible that they're not, that they're extraneous solutions. So we're going to take these really fast, this x minus 5 and this x minus 8, and we're going to substitute them back up into the top just one at a time to make sure that they do or they do not work. So let's do that real fast. Let's say I put negative 5 in there, so I would have negative 5 plus 9 minus 7 equals negative 5. Well, negative 5 plus 9 is 4. 4 square root is 2, so I'll have 2 minus 7 equals negative 5. That's negative 5 equals negative 5. That one checks out. So negative 5 is the solution. Let's put negative 8 in and see what happens with it. So negative 8 plus 9 minus 7 equals negative 5. I kind of have a mess here, don't I? Negative 8 plus 9 is 1. The square root of 1 is 1. So I have 1 minus 7 equals negative 5. And 1 minus 7 is a negative 6. Negative 6 does not equal negative 5. So this is not a solution. It's called an extraneous solution when it doesn't work. So our only solution to this equation is x equals negative 5. This next problem is completely done for you again. It kind of just shows you that sometimes we have such complicated radical problems here that we have to do the radical twice as far as solving it. So we're going to first separate them on both sides of the equal sign, square, but when we squared this turned out into a crazy FOIL problem. We're going to FOIL that out, and then we're going to isolate the radical again because there's another radical, and then get it set equal to 0, and then solve, and then check and see what happens. So this is a great example here for you to go back and look at if you're having problems on how to do it. This one is worked out step by step for you to do on your own. So this last problem right here is already isolated. We have a radical on both sides of the equal sign. So right off the bat, I can just square these the way that they are. When I square the first side, I get x plus 2. But when I square the second side, I really have to FOIL that out. I have 2 minus the square root of x times 2 minus the square root of x. And I have to do the multiplication there. So I'm just going to rewrite it as I go. I'll have 2 times 2, which is 4. 2 times a negative square root of x. And then I'll have a negative 2 times, or a negative square root of x times 2, which is the same thing twice. I get negative 2 square roots of x and negative 2 square roots of x, which is a negative 4 square roots of x altogether. Then I have the square root of x times the square root of x, which is really just x, because that would be the square root of x squared, and the squared and the square root cancel each other out to just be x. Now I wish I was getting close to done here, but I'm not. I have another radical, and in order to solve for a radical, I have to isolate it. So first thing I'm going to do then is get all of the radical stuff by itself. So I'm going to subtract the 4 and subtract the x to the other side. So it cancels over here, which is why I did it. And then over here we get pretty lucky because those x's cancel over here, and I'm just left with negative 2. So I have negative 2 equals negative 4 square roots of x. I'm going to continue to isolate this radical and divide by a negative 4. So I get 1/2 equals the square root of x. Then I'm going to square both sides, so I get 1/4 equals x. So this is interesting that we only got one solution, and we really probably just need to check that real fast to make sure that it worked. So we get 1/4 plus 2 equals 2 minus the square root of 1/4. So 1/4 plus 2 would be 2.25, and 2.25 square root would be 1.5. And then the square root of 1/4 would be 1/2, so 2 minus 1/2 would be 1.5. So these checked out, so 1/4 is my solution.